Hey guys, this is Junior Scientist. Welcome back to the channel. And we have just started a series of lectures for different subjects. And in today's lecture, we will discuss about chemistry. It is the third chapter of chemistry IGCSE from the Cambridge board's book. And it is just the topic number 3.1, which is representing the periodic table and classification of elements. You should be clear with the fact like periodic table is simple arrangement of elements on the basis of increasing proton number. So that was the well accepted model was given by the Mendeleev. What he did is he added certain elements, he gave some sort of blocks to them, and what is amazing it was that he left over blanks for the elements which were not discovered at that time. Even he told the chemists of those of that time about the properties of those missing elements. And now, if we discovered certain elements and it resembled to the similar properties which he gave, we are going to put in those elements in that periodic table. So it was a well accepted one. Until now, we are using that periodic table which was given by Mendeleev. The first point is that in the periodic table, how different elements are arranged. The elements are arranged in the order of increasing the proton number. What the proton number is, basically, an elements have two major factors. One is the atomic number, other is the atomic mass. When you simply consider its proton number is simply a positively charged subatomic particle, and that's it. So simply you're going to have the proton only. But when we take proton plus neutron, which is the neutral one, it carry no charge on it. So if you're going to put in these two values, the two bigger values, they will give rise to atomic mass. But if you only take this value, the proton number, this is called as simply the proton number or atomic number. Now, what they are saying is that elements are arranged in the order of increasing the proton number. What do you mean by this thing? Is like this way, when you move from left to right side, elements will see a great increase in their proton number. So simply they will have more proton number. I mean, like, and they are going to show as soon as you move downward, that is the period number. So simply when you move from left to right, that is called as the vertical columns of the elements with similar properties. So simply in a group, one element may have similar properties. And what do we mean by this thing? We will consider the group number one, which is arranged like this way. So this is the group number one and group number two. So all of the group member of group number one and group number two are having almost similar properties, and they most of them are metals. Now what the metals are, basically they are the two huge groups. One is metal and other is the non-metal. The metal are simply donor of the electrons, and another category is that metal which is able to donate maximum electron, or which feels happy, or which donates its electron immediately, will be termed as a good metal. But when it comes to a metal who takes time to donate its electron and it is unable to conduct electricity, it will be categorized as the like a bad metal. So simply that is how we can categorize them. Now, the first thing is like about groups. When you move from top to bottom, we might see increase in the in number of shells, just like this way. So if we just consider size of lithium, this is the size of lithium. When you move downward for the francium, it will be the bigger one. Why? What is it and why this happens? So because as soon as you move top to bottom, reactivity increases for the entire periodic table except for the noble gases and group number 7, which is the halogen. Now simply when you move from top to bottom, elements will see greater number of protons available on them, and the one who is present at the top will obviously contain the less number of protons onto it. Next factor is that as soon as you move from top to bottom, let's say from lithium to francium, the thing is number of shells will also increase. When number of shells will increase, the number of electrons will find a space to occupy that space. So simply the thing is that they will be moving away from the nucleus. So the more distant they would be from the nucleus, the more it would be easy for us to grab those electrons or to separate them. So simply it will feel happy to donate those electrons. It will be getting like reactive then. Why? Because they feel happy to donate a maximum number of electrons. So that's it. Next point is that when it comes to the period number, when it comes to the period number, the groups like this way from left to right and left to right. But in this case, the case goes a bit inverse. They got smaller in their sizes. You should be clear when you move from top to bottom within a group. The number of shells increases from top to bottom, and the number of electrons will also increase up. They will happy to donate their electrons. So you could simply say reactivity increases from top to bottom. So as soon as you move from top to bottom in the periodic table, the reactivity will increase. But when it comes to the other case, it's when you move from left to right, the reactivity will the activity will decrease, and the number of shells will also decrease. Why is it so? Because we are moving from metals to the non-metals, and in this case they will try to the non-metals are the thing which are going to attract the electrons given by the metal. So simply in this case they will accept the electron, and their size will getting smaller, smaller and smaller. Okay, so that is the case till this point. Now, another important group is that when it comes to the group number seven, it is about the group of halogen, like this one, that is the halogen group. In this case, that is the most distinctive feature. When we move from top to bottom, reactivity decreases. What is the reason behind it? The reason behind is that when you move from top, they are well known for a case which is called as electronegativity. Now, what electronegativity is that when you move from top to bottom, oh sorry, when the negatively charged group finds any electropositive group, or basically when a non-metal find a metal, it would attract its electron with the greater force. This is called as electronegativity. And fluorine is said to be the most electronegative element in the periodic table. Its electronegativity value is 4. Now, if you place hydrogen nearby it, what this fluorine is going to do, it is going to attract the electrons of this, and then they will tend to react with each other. Now, when they react, simply we could say that fluorine is the most reactive element, most electronegative element. So that is how it can attract, and obviously, when it can attract, they are going to react with each other. So is the case for chlorine, bromine. When it comes to iodine, till iodine, the size increases, the number of electrons also increases, but the tendency, the electronegativity potential decreases from top to bottom. So simply fluorine is the most electronegative element, and when it comes to iodine, the electronegativity will be decreasing. Next is the case when it comes to the noble gases, which is basically the group number 7. When it comes to this group, in this case they are not going to react with anything else at their natural position until you forcefully make them to react with something else by disturbing them. However, they are best known for not reacting with anything else. They will not react. Why they won't react? Because they are known as a standard for the stability. Because the outermost shell is fulfilled, they are stable, so that's why they are not going to react with anything else. Another thing is that any element reacts with other elements to attain the stability, to fulfill their outermost shell, because mostly they contain an odd number odd number electron in their outermost shell. So in order to get rid of that odd number electron, they will react with the given metal or a non-metal. So if there is a metal, just like sodium, if sodium contains like 11 electron in its outermost shell, chlorine will contain 17 electron in its outermost shell. So sodium will gradually feel happy to donate its electron because both are in the odd number. So sodium is a metal. He will donate its electron to a non-metal, which is chlorine. Chlorine will accept it, and then both of them will attain this stability. So that is the reason why something is reacting with each other. Now back to the noble gases. When it comes to the noble gases, they are not going to react with anything else because they are in the stable form. So simply they are known best for because their outermost shell is fulfilled, and when their outermost shell is fully fulfilled, they are going to they are not demanding electron from anything else. So that is why they are stable. Okay. Now here is something which is given as elements in group number 1 to O. It means elements like from group number 1 to 0, or basically group number 8 are the noble gases. From metals to noble gases, these are the main group elements. Usually general groups, generally we study the first group as the alkali metals. They are known best for their reactivity. When it comes to the group number 2, they are the alkaline earth metal. Their reactivity slightly decreases. When it comes to the transition metals or transition elements, they are hard, strong, and dense metal. And the thing is that when it comes to transition elements or transition metals, they their outermost shell or their d subshell is usually subshell is usually like partially filled. So that is why they contain multiple valencies of them. When it comes to the poor metals, like this group, it contains like they are basically the those metals which don't feel happy to donate their electron, or maybe they consume some time to donate their electron. Next, it comes to the metalloids. They are the semiconductors whose properties vary gradually between the metals and non-metals. So, sometimes it attains properties of metals, sometimes it attains properties of non-metals. When it comes to silicon, now silicon has an amazing property. Basically, it can make a bond with itself just like carbon. So it is called as sometimes, so they are going to make a bond with each other. But when it comes to carbon, carbon is best known for creating all four bonds with itself. This is called as catenation. When it comes to the non-metals include group number 7, halogens. They are called as halogens. They are known as, you could say that, known as best for their electronegativity because they are going to extract the electrons of positively charged groups. When it comes to the noble gases are very reactive, very unreactive. They are not going to react with anything else because they are stable. They don't need to donate they don't need it to donate electron to anything else. Neither they need someone to accept its electron because they're in the stable form. Okay, so that's it for today. I hope the video must have helped you. So in today's lecture we have just covered periodic table, classification of elements. We have studied about metals, about non-metals. We have studied about the noble gases. So basically, when it comes to metals were those groups who are usually positively charged and they feel happy to donate their electrons. So the metal who can donate electron, at the best of it, it would conduct electricity. When it comes to a non-metal, non-metals are something who are the electron acceptor. So they will readily accept the electron which were donated by the metals. When it comes to noble gases are acting as the standard of stability because their outermost shell is fulfilled and they don't need anything to get reacted to them. Nextly, we just discussed about the transition metals. Transition metals are basically known because because that element has a partially filled d subshell, or they can give rise to cation with an incomplete d subshell. So basically, they contain partially filled subshell, and they contain multiple valencies among them. So that is how we just learned about today. And don't forget to click the right button. See you in the next video. You can share a suggestion. See you in the next video. Good luck.